Hello. You're early today. Thanks for already opening the store.
Oh, hi. Well, actually, I spent the night here working on the request of our last client.
Sounds terrible. What did that customer ask for?
Well, she's a witch, and her originally black cat, Kiki, has turned violet after she gave her a happiness potion. She told me the potion is plant-based and that Kiki is allergic both to basil and to catnip. And she wonders whether it could be an allergic reaction.
Sounds plausible indeed. So, given those facts, which form a very simple database, it is just about evaluating this query, asking whether the potion contains some ingredient to which Kiki is allergic, right?
I think I understand, but the data is missing some information. It doesn't tell us anything about the ingredients of the potion.
Then you need to consider some additional knowledge. Have you consulted the ontology of alchemy and tried to reconstruct the potion's recipe?
Yes, I tried that, but those are very general rules and I wasn't sure how to apply them correctly.
Let's take a look. I see you already spotted 4 relevant rules. The first one says that if X is a happiness potion that affects Y, then X must contain some ingredient Z that Y likes.
Yup, and that's why the database seems incomplete. We know that X matches the potion and Y matches Kiki, but we don't know any ingredient that the potion contains and that Kiki likes.
Well, let's introduce a fresh element in our database to witness that such an ingredient must exist. What is the next rule?
The next one is easy. It just says that whatever is plant-based can only contain plant-based ingredients. So, following your logic, we know that the fresh element must be plant-based.
Exactly. And as the third rule tells us, if a cat likes something that is plant-based, then this something contains catnip.
But the fourth rule just expresses that the contains relation is transitive. That means that the potion itself must contain catnip. So it was indeed an allergic reaction. I will send the antidote so that Kiki can go back to black again.
Speaking about black things, let me get a coffee. And let's recap the approach we just used while I prepare it.
Alright, so we evaluated a query on a database. Our query was a good example of a Boolean conjunctive query. Such a query asks whether a conjunction of atomic facts that may involve some unspecified objects is satisfied. The database satisfies the query if there is a homomorphism of the query into the database. And a homomorphism is just a mapping that preserves all the facts. This is easily grasped if you represent both of them as graphs, just like that.
Sure, but in practice, data might be incomplete, and it is useful to add some background knowledge to the picture. This often comes in the form of existential rules. Such a rule consists of a body that implies a head. Both of these are conjunctions of atoms, as in conjunctive queries.
So, no negation, no disjunction.
Indeed, only conjunctions. And they are called existential rules because the head may require the existence of some additional objects not mentioned in the body.
I understand, but what does evaluating a query even mean in that context?
Well, since the data might be incomplete with respect to the rules, you now look at all possible ways to complete the data so that the rules are satisfied. Each possible completion is called a model, and we want the query to hold in all models.
Wait, that's exactly not what we did earlier. We introduced some fresh elements to satisfy the rules and only checked the query against that specific model. But there were more models, like this one or this one. Should I prepare an antidote to the antidote?
No, don't. There is no need to worry. This procedure of introducing fresh elements on the fly is called the chase. And if the query holds in the result of the chase, then it holds in every model. Can you guess why?
I see. This comes from having introduced fresh elements in the most general way, and from everything here being preserved in homomorphism. Take the body of rule, for example. If there exists a homomorphism of it into some database, and this database itself has a homomorphism into another one, then surely the body of the rule also maps into the second database. This means that even if the fresh element we introduced is in reality a known object, say it was actually Basil for the potion, then the rest of the chase still needs to apply, and therefore it won't change the answer to the query.
Exactly. The result of the chase is therefore called a universal model. This means that it has a homomorphism into every other model. And to evaluate a query, it is therefore sufficient to look at the result of the chase. Hello, sir. What can we help you with today?
Hi. I've heard a lot of good things about your logical approach to alchemy. And I was wondering whether you could help me with this cryptic set of existential rules I found on a mysterious scroll. I don't know what this predicate P is supposed to be, but what would happen if I found some?
Let me handle this. I know everything about the chase now. So, imagine having some predicate P already, that's our data, and we have these two rules. The first one applies here. Boom, fresh element. Oh, it applies again. That's another fresh element, correct?
Correct. Introduce as many fresh elements as you need. You could also apply the second...
First rule again, and again, and again. Alright, I think we will end up with an infinite chain, sir. So that set of existential rules sounds quite dangerous to me. How much time do you have?
Take all the time you need. I'm a vampire. I'm immortal.
Okay, then just get a cup of tea, of blood, sorry. And we are done. Here is your universal model, sir. Do you need a gift wrap?
Wait! Didn't you forget something? What about the second rule? You could have applied it almost from the very beginning, but you postponed its application for infinitely long. So what you obtain here is not a model at all. Look, the second rule is not satisfied here, nor here, nor here.
Oopsie. What shall we do then when there is such an infinite chain?
You need to be fair, that's it. Do not postpone the application of a rule forever. If a rule is applicable at some point, then you must apply it after finitely many steps.
I see. I could, for example, imagine that I place those possible rule applications in a queue, and that I always pick the oldest one at each step.
Sure, although you may postpone some applications a little bit if you want, but not forever. A chase sequence that respects this fairness condition will always end up producing a universal model.
Alright, there you go, sir. Here is your universal model. For real this time.
Thank you. Ah, and even fair trade, if I understood properly.
Hello! How may we help you today?
I just saw your previous customer exit with an infinite universal model, and I was a bit concerned as I have the same set of rules. But I come from the real world, in which databases are finite objects, so I cannot afford such an infinite model. Can you do anything for me?
Oh, I presume Mr. Real World is interested in decidability.
Precisely. If I know in advance that the chase terminates, then I can just run it and wait. However, if it seems to run forever, then I don't know whether I should wait longer or whether it won't terminate. And I have a query to evaluate. I can't wait forever.
Well, I have bad news. Pretty much everything here is undecidable. Evaluating a query in presence of existential rules is undecidable. As you said, if you know in advance that the chase terminates for your set of rules, then it gives you decidability. However, telling for a given set of existential rules whether the corresponding chase will terminate on every database is also undecidable. The best we can do is to offer a chase variant that will terminate in more cases.
I think I've got it. Look, we start again by applying the first rule, because that's all we can do. But then we apply the second rule instead of going further along the chain. And now, to be fair, we still have to examine these three possible rule applications. But none of these is truly necessary, as the fresh facts that would be introduced are already there. The head is already satisfied in the database.
Well done. you just applied a chase variant called the restricted chase. As you figured out, it does not apply a rule if there already is an homomorphism of the fresh fact it would introduce into the database. And indeed, in this specific case, if you apply the rules in a smart order, it terminates.
Wait, the model you sold to the previous client was universal, right? And you claim this finite one is also universal? So the big one should fit into the small one. How is that possible?
Simple. Here is the homomorphism you're looking for.
Impressive! Thank you! I'll still take the small one.
Phew, we were lucky with that customer. Not all sets of rules admit a finite universal model, you know.
Yeah, I can imagine a very simple one that will never terminate, like that one here. We cannot do better than an infinite chain. But when there is a chance for it to terminate, is the restricted chase our best shot to detect that?
Well, not quite. I am aware of a forbidden arcane, a more refined version, whose secret name is the core chase. Take, for example, this rule set.
Oh wait, let me first run the restricted chase to see what happens. I'm pretty sure that whatever rule order I pick, it will always be infinite. However, I'm also convinced that this finite model here is universal.
It is indeed, and the core chase can help you find it. So, the core chase is really careful. After each rule application, we check whether this produced database has a homomorphism into itself that is not a bijection. And if so, we collapse the database accordingly until we obtain a database whose only homomorphisms into itself are bijections. That's called a core.
Okay, let me run it to see whether I understand it correctly. We apply the first rule, no choice. I check whether the result maps into itself in a non-bijective manner. Clearly not. Let's now apply the second rule, which introduces this new fact. Now the database could collapse into itself in a non-bijective way.
No hesitation. Collapse it before the chase goes infinite.
Alright, there it is. We obtained the universal model I was thinking about. Impressive!
Yes, the core chase terminates if and only if there exists a finite universal model, in which case it produces such a model.
So it terminates if and only if it is possible to terminate? That's really neat. But wait, what's again the difference to the restricted chase? There we also check whether the fresh elements were not already present in a sense.
Sure, the restricted chase also performs this kind of check, but on a local level, only for the freshly introduced elements. The core chase checks whether the whole database maps into itself, not only for the head of the rule you try to apply. This produces a very elegant chase, but it is much more expensive to construct for people from the real world, with only limited computational power.
I can't wait for the next customer. Now we have this nice chase procedure to complete data by taking existential rules into account. Let me recap what I just learned regarding the use of the ontology of alchemy.
Don't forget about fairness this time.
Yes. I swear never to postpone a rule application for infinitely many steps again. Fairness guarantees that the chase produces universal models.
And what do you do for those clients interested in chase termination?
Well, we can offer more refined variants of the chase, like the restricted or the core chase that terminate in more and more cases. But I always remind them that there are no guarantees because the problem is undecidable in general.
And don't forget to charge extra for the core chase that terminates if and only if there exists a finite universal model.
I will remember. But for now, let's call it a day. I have to catch up on sleep.